Question 7, we have a projectile or a camogie player wishes to improve her accuracy. She's standing 35 meters away from the goal line and her initial velocity is 20 meters per second and the angle is alpha. So the initial vector is 20 cos A in the I direction plus 20 sine A in the J direction. We have to derive an expression in terms of alpha for the time taken to reach the goal line. So the displacement in the x or the I direction is 35. So because there's no acceleration in the I direction, s of x is just equal to ut. So 20, my initial velocity 20 cos alpha times t is equal to displacement, which is x. So the time taken to get 35 meters is 35 divided by 20 cos A. 5 divides into both of these. 7 over 4 cos A for part 1. We're asked to calculate the values of alpha such that the sliotar hits the crossbar. How high above the ground? 2.5 meters, and it's the same distance in the x direction, so we have the time. So displacement in the y or j direction is 2.5. So ut 20 sine alpha times t, which is 7 over 4 cos alpha, ut plus a half at squared, so that's minus g over 2 minus a half a by t squared, which will be 49 over 16 cos squared alpha will be equal to 2.5. This normally tidies up nicely. I don't think it is though. I'm gonna get here 20 into 4 into 20 goes 5 times. I'm gonna get 35 sine over cos is tan. I've tried a few times to simplify this down, but it's the decimal it's given me is minus 15.00625, so I'm just going to leave it as 15, and that will be times 1 over cos squared to put just one extra step in, and then bring the 2.5 across equals 0. So 35 tan alpha minus 15 times 1 plus tan squared alpha minus 2.5 equals 0, just getting our quadratic. So 35 tan alpha minus 15 tan squared alpha minus 2.5 is equal to 0. Multiplying by minus 1, we're going to get 15 tan squared alpha minus 35 tan alpha, and we will have minus becoming a plus 17.5 is equal to 0. You could use the minus b formula at this point, or divide by 5 to get 3 tan squared alpha minus 7 tan alpha plus 3.5 is equal to 0. And using the quadratic formula here, I get tan alpha is equal to 1.6076 or 0.7257. So these values give me alpha to be corrected 2 decimals, 58.115, 58.12 and 35.96 degrees for the two angles for the camogie player. In part B, we have a stunt cage of a circus, but it's really a circle. The diameter is 20, so we'll need the radius at some point. The radius is 10 for the big sphere. We have a motorcyclist at M, moving with uniform horizontal circular motion. So we're probably dealing with mv squared over r. Tan of B is 4 over 3. Tan is opposite over adjacent. leaving a 5, so the cos of b is 3 over 5, and the sine of b is 4 over 5. Set this up straight away. We're looking for friction being ignored, the force is acting on M. Okay, so here's M. We have mg coming down. We have the reaction towards the center. We have our angle beta in here, so we have or cos beta on this side and or sine beta opposite the angle, or sine beta. So these are the forces involved. We're asked then to find the velocity of M. So forces up and forces down. I have or cos beta in the arrow of the wrong direction. It should be this way. So or cos beta is equal to mg. I think that's all that's going up and down. Or cos beta is equal to mg, and or sine beta will be equal to my mv squared over or. So let's have a look at this. We have the cos of beta is 3 over 5, so we have 3 or over 5 is equal to mg. So we get an expression for or here. 5 mg over 3 is equal to or. Need to be careful with our radius here. The radius of motion here is this guy here. This is 10. So this is going to be 10 sine beta over this side. It's a bit of a nasty one, I think. 10 by 4 over 5 is 8. So 8, we deal with meters, is the radius of motion for this one here. So or by the sine of beta is equal to mv squared over 8. So 32 or over 5 is equal to mv squared. So replacing or to get 32 over 5, and we have 5 mg over 3 will be equal to mv squared. The 5's cancel. We divide by m, we're going to get v is equal to, we're just left with 32g over 3, the square root of 32g over 3 meters per second. As a decimal, let me just check this as a decimal. I'll ask for as a decimal, I'll leave it like this. So the student's second modeling introduces friction. Draw a diagram to show the forces when it's at the point of slipping. What are my forces? F is equal to mu or. So if m's on the point of slipping here, we still have the reaction towards the center. Force will be perpendicular wherever it's going. So my force in this direction. If I put my angles in, I have my beta or cos beta and or sine beta. Because this is 90 and this is 90, it means that this angle in here is beta. So my force is involved here over this side, F sine beta, and down here F cos beta. So if we also have mg, actually don't we, mg. So if we create a few equations here, we might be able to solve when the velocity is 7.5. So what have I got? I have mg equal to f sine beta plus or cos beta. That's up and down, left to right. I'm going to get or sine beta minus f cos beta is equal to mv squared over r. So the easiest way of substituting here, I think the best way is to equate two values for r. So the force at the point of slipping is mu r by the sine of beta, which is 4 over 5, plus r by the cos of beta, which is 3 over 5. That's equal to mg. So I can get mg is equal to 4 mu r over 5 plus 3 r over 5. So it's 4 mu r plus 3 r over 5. So 5 mg is equal to, r factored out would leave 4 mu plus 3. So r is equal to 5 mg over 4 mu plus 3. We should be able to simplify r in the other equation too. So r sine beta, we have 4 over 5 times r minus the force of slipping mu r by the cos of beta, 3 over 5 is equal to m, and v is 7 over 5, 15 over 2. So that squared is 225 over 4. And the radius, in this case, be careful with the radius. As we saw before, it was 8, or is equal to 8, 10 by the sine of beta. So just simplify that down, be careful. That's going to be 225 on top, and 4 times 8, 32 on the bottom, times m. So we're going to have, if I multiply by 5, maybe, if that makes sense, 4 r minus 3 mu r would be equal to 225 by 5, 1125 m over 32. I don't know if this is going to work. Let me see. R by 4 minus 3 mu is equal to 1125 m over 32. So R is equal to 1125 m over 32 times 4 minus 3m. These are lovely questions. They're so easy to work out. So if I equate these two things, 5 mg over 4 mu plus 3 equals 1125 m over 32 times 4 minus 3 mu. I'm losing the will to live. My mu is changing to m. 3 mu. Let me see. Divide by m. Cross multiply by 32. That helped me. Might as well just multiply it out. Actually, 5g and tidy it up over 4 mu plus 3 equals 1125 over 128 minus 96 mu. So can I get mu on its own? Go this way first, maybe 4 mu by 1125, that's 4,500 mu, plus 3,375 is equal to 5g by 128 minus 49, 5g's 49 by 96 mu. I'll just get a calculator. Minus 4704 mu. So we're going to get 4500 mu plus 4704 mu equals this guy, 6125 minus 3375. That looks like 9204 mu is equal to 2750. I hope to God this is right. Mu is equal to 2750 divided by 9204. somewhere in the region of 0.298 is what I'm getting for mu 2987. So 0.298. I'm just seeing a mistake. I'm checking my answer. This is actually 6272. Making this one 2897. I'm making the answer 0.31475. So whatever way they want that rounded will be your final answer for this really tasty question.